Welcome! Today we're talking about how to find the area of trapezoids. So first let's review the other quadrilaterals that we've looked at so far. We found the area of a rectangle. We used the formula A equals L times W. We have found the area of a parallelogram. We used the formula A equals base times height. And we found the area of a kite. We used area equals 1/2 times the first diagonal times the second diagonal. But what about trapezoids? As long as we're looking at quadrilaterals, let's look at some trapezoids. Now the thing with trapezoids is that they can look a lot of different ways. But the one thing they have in common is that there is always one set of parallel sides, and we call these bases. We can use the distance between the bases as the height of the trapezoid. Now there is a cool thing that happens if we duplicate a trapezoid and rotate it 180 degrees. So watch. Here we've duplicated. Let's rotate it. And then let's just slide these back. And look, together they make a parallelogram. Now we know how to find the area of a parallelogram. So if we can find the total area here, the total blue area, eventually we'll have to divide it by 2 since we doubled our original trapezoid, and that's really the only area we want. But area of a parallelogram is pretty straightforward. So the height of the parallelogram, something we need for that formula, is the same as the height of the original trapezoid. That part's easy. You're given the height of the trapezoid, that's also the height of the parallelogram. The base of the parallelogram is where it gets a little weird, because it's a combination of the original 2 bases in our original trapezoid. Here's the bottom base, we'll call it base 1, and the top base, base 2. But remember when we duplicated and rotated that trapezoid, that base 2 at the top flipped around to the bottom, and now the entire parallelogram from left to right includes base 1 and base 2. So we can say B1 plus B2 for that entire parallelogram base. If we substitute all this into that parallelogram formula, then we have the area of the parallelogram equaling B1 plus B2 times the height. Now don't forget, eventually we will need to divide by 2 because we really only want the area of a trapezoid. So here's the formula all put together. Area of a trapezoid is the sum of the bases, that B1 plus B2, times the height, and then divide by 2. Let's do an example. Here's one of our trapezoids from that first slide. We're going to say it's 4 units high, it has one base that's 3 units, and one base that's 8 units. So that first part of the formula, the sum of the bases, where it says B1 plus B2, let's go ahead and look at that first. The sum of the bases, we'll do base 1, 8, plus 3 for base 2. But really, it doesn't matter which base is base 1 and which one's base 2. We're just adding them, and we get 11 no matter which order you add them. Then height, the height's here's 4. They already told us that. So let's plug those numbers into our formula. The B1 plus B2 group there is going to become 11. And then the height will become 4. And now we can start to simplify. 4 times 11 is 44. And then 44 divided by 2 is 22. So our area here is 22 square units. So as long as you have this formula written down as a reference, or if you decide to memorize it, it's a pretty straightforward formula to use when you're given both bases and the height. Where it starts to get a little complicated is if you're given the area. So let's try this backwards. We have a trapezoid here. We know the area is 52 square units, and we know both bases. We know there's a base that's 4 and a base that's 6. I want to know, what is the height of this trapezoid? So here's our formula again. Area equals the sum of the bases times the height divided by 2. Now, the area is 52, so we'll plug that in on the left. The sum of the bases, 6 plus 4, is 10, so we'll substitute that. As we start to simplify, one step we could take is to divide the 10 by the 2. So we'll have 52 equals 5 times h. And then we'll divide both sides by 5. And this is not going to come out to a whole number, but that's okay. Measurements don't always come out to whole numbers. So our final answer, 10.4 units, is the height. But what if you're given a trapezoid and you have the height, but you're missing a base? We know the area of this trapezoid is 36 square units. We know one of the bases is 8 units long and the height is 4 units, but we need to know the other base. Now this is one of those, again, we don't know which base is the 8. We don't know if it's the top or the bottom, but again, it's not going to matter because when we add, we can add them in any order. We'll probably just call this base 1 because it's the one that we have. It's our first one that's given. We'll just call it B1. So the area is 36. Let's put that 36 in for A. And we're going to go ahead and put the 8 in for B1. And then the 4 in for H because that's our height. Now that we've got everything substituted in, let's go ahead and start simplifying. Now since we have something on the right times 4 and then divided by 2, we can simplify the 4 divided by 2. Just to get 2, because 4 divided by 2 is 2. Now, though, you could, if you wanted, distribute the 2 into those parentheses, but I feel like it's a little simpler if we just divide both sides by 2. So we'll have 18 equals 8 plus B2, and we'll just subtract the 8s from both sides, and we get 10 units being our B2. So our 8 unit base actually was the top one that looks shorter, and the 10 units, B2, would have been the bottom base. But now you've gotten lots of practice with that area of a trapezoid formula. You've worked it when you were given all 3 dimensions. You've worked it when you were given area in only 2 dimensions and flipped that around all kinds of ways. So thank you so much for joining me for our talk about area of trapezoids. Good luck with your practice, and I'll see you next time.